we are at the point we are ready to take some notes. So with our notes today, I'm going to show you the first example, and then you guys are going to help me with the second example, and then with the third, you're going to try doing it on your own, and then I'll be here to help you if you get stuck. Okay, that's kind of where we're going to be going. Some of you, I know I've already used this method, so maybe you can help me with it a bit. All right, it is time for notes. Here is my paper. Last time we talked about systems. We are still talking about systems. In algebra and in the other math later too, geometry, algebra 2, you're going to need more than one method for solving a system. First method is graphing, works every time, but it can take a long time sometimes. This method, we're just going to call it the second one. Let's call it method 2. The number isn't important. What's important is that you know how it works. And this method is called substitution. So let's come up with an example. Let's say, and I don't have a word problem for us to do today. We're not going to do like a fundraiser or anything, but we could have used this in our fundraiser problem, and if some of you have, or we could use it in any kind of like real life problem that we'd run across. But for today, I'm just going to give you the equations, and we're going to work to solve them. So let's say we had this. Let's say we had a slope-intercept equation. Let's say it was, we're going to number this number 1. Let's say it was y equals 3x. Okay, yeah, so y equals 3x is one equation. And then let's make our other equation. Let's say we had a standard form. Let's say we had x plus y equals negative 32. So those are 2 equations in our systems. Would you post in the chat, what do you notice? What do you wonder about both of those? If anything, do you notice anything? Do you wonder anything? As you're going through and solving a system and you're figuring out what method you're going to use, you're going to want to be asking yourself, oh, what do I notice? What do I wonder? It's going to help you when you decide which method you're going to use. Thank you, Tina. Thank you, Mateo. Anyone else? What do you wonder? What do you notice? Thank you, Audrey. Thanks, Ethan. So here's some ideas. Thank you, Maya. Tina's already moving ahead and thinking about doing the substitution. Mateo's noticing the x and y's have the same value. Audrey is wondering if we're going to use tables. We're not going to use tables, but that would actually be another method. Maybe if you wanted to, you'd call it method 3. You can solve systems with tables. Ethan notices there are 2 different equations. Let's see. This person notices one's in standard form. This person wonders if we're going to be substituting in for x. Moving ahead with substitution. The equations are not really similar with the numbers. I noticed at least one of the x and y's is a negative, and we can substitute y for 3x. Yeah, and one thing I noticed too is if we were going to graph it, we might get some really large numbers from this one. And this one, I noticed that the y-intercept is 0, and the slope is 3. So good, lots of wonderings and noticings, and some of you are already moving ahead with substitution. So what we have here is we have 2 equations. We have x's and y's, and remember, the x is just where are we on the x-axis. Oops, it would be side to side. The y is where are we on the y-axis. So this is a really cool thing that's going on here. Y is 3x, right? That's what that equation says. but y also shows up here. So you know what? If you know that y is 3x, what we can do is we can actually rewrite this equation, and instead of writing it with y's, we can write it with x. This is called substitution. The substitution step looks like this. You'd have x plus, and not y anymore. Instead, I'm going to use this 3x instead. You can do that because these y's are the same thing. Okay, and now, hey, look at that. We just have one variable. So let's combine like terms. If we have one x and 3 more of them, then that means we have 4 x's. And now we divide both sides by 4 to get the x all by itself. See, negative 32 divided by 4 is going to be negative. What would that be? 8. So what we've done is we've solved for x. And what this means in our problem is it means wherever these lines are going to meet, it's at the x value of negative 8. Now, here's a problem. Some students stop right here. You can't stop here. We have to figure out the y value of where they meet as well. So we have a choice. We can either use this equation or we can use this equation to figure out our y. It's totally up to you. I want to use this one because I'm thinking it's going to be one step. If I plug in a negative 8, all I need to do is multiply by 3, and that's going to tell me my y. So I would write it like this. I would write y is 3, but instead of x, I'm going to go times negative 8 because I know that x is negative 8. Okay, so what was that? 16, 24, negative 24, I believe. That's my answer. That's where these two, oh, and you know what, let me write it out here. Y is negative 24, unless I made a mistake. If you guys see it, please let me know. But that's going to be where the lines meet. Questions, comments, concerns, wonderings? We found x, and then we used it to, and we found y. How do you feel about this method? What are your thoughts? Do you like it? Do you not like it? Cool, thank you, those of you sending me messages, awesome. Okay. So we had our equations. We noticed that one of them told us what y was, so we substitute in that number, and then because what that does is it gives us just one variable, and we can solve with one variable. And so we solve, and then all we have to do is go back and figure out the other one. Okay, for this next one, I want your guys' help. I want you to help walk me through it as we solve it together. So here's problem 2. Let's see, we're gonna do, let's do a couple standard form ones. Let's go 4x plus 3y equals 14. And then our other equation, and you know what, I'm gonna write the other equation over here this time just so that they're side by side. Negative 2x plus y equals negative 3. So 2 standard form equations. We want to find out where these systems meet, where they both have the same x's and y's. Now this is a little bit different than the one before. The one before we had standard and slope intercept. And so what I did is I took the slope intercept part and I plugged it in. Now we have 2 standard equations. So there's actually a little bit more we have to do here. Can you guys let me know, what would you do for your first step? Thank you. So Tina says over here, let's solve for y first. And when people say solve for y, they mean let's get the y on its own. So I would do that by adding 2x. And so we'd have y equals, and then in slope we always put the x's first because the 2 is our slope. So we'd write 2x minus 3. Yes, now it kind of looks like the problem we did before, right? All right, guys, let me know what do we do next? Thank you, Ellie. Thank you, Tina. Yeah, so we're going to be focusing on this, right? We know we have our y now, and we know there's a y here. So this is the piece that we're substituting it in. Good, so we'd write it like this. 4x plus 3, and it was y, but instead of y, we're going to do 2x minus 3. So I'm putting in parentheses because there are 2 pieces to that, right? The 2x and the minus 3 equals 14. I should have done a better job kind of writing that, but that's where the 14 came from. This is the 4x, and then the 3y is that. And that is your substitution step. This is your purpose today. Your purpose is to be able to use substitution to solve systems. And that's that step that we just did. All right, keep going. Help me out. What do we do next? Solve for x. Yep. Solve the equation. I see we have a distributive property to take care of first, right? 3 times everything in here. So we have 4x plus, this is going to be 6x. And now a positive and a negative is going to be a negative 9. And there's the 14. Remember, we have like terms here. Whenever you end up with like terms, you always want to take care of them. You always want to put them together. Don't leave them separated. If we have 4x's and we have 6x's, then that means we have 10. So 10x minus 9 equals 14. We add 9, right? Solving equations. This is how we started the year in algebra. Solving equations like this. 14 plus 9 would be, what, 23? And then what do we get for our x? I think that's going to be a nice decimal. We can write it as a decimal. It's totally up to you guys. If you want, you can do fractions, decimals, improper fractions. It's totally up to you. All are acceptable. Yeah, I agree with you. I think that would be the best one. 2.3. All right, what should we do next? We're not done. Some people think we're done here. Okay. And you know what, everyone, I want you to do this though. In my class, it's really going to be helpful if you do this. Start to make your ordered pair and fill in what you know. That way it reminds you that you still have to find the y, okay? Yeah, so people are saying, okay, now let's substitute in the x. Yes. We have one person saying, let's use the second equation. Someone else saying in the y equation right here. We kind of have our choice. We have 3 we can choose, right? We can choose this one, we can choose this one, or we can choose the one that we made. Pick whatever one's going to be easiest for you. I'd agree. I think this one Yeah, I think this one's going to be the easiest. So our y is going to be 2 times 2.3 minus 3. So our y is, what is that, 4.6 minus 3? Ooh, that's a nice subtraction. That's just 1.6. Yes, sometimes you get decimals, sometimes you get fractions. It's fine. You just stick with it. So this would be a really tough one to graph. If we graphed it, I don't even think we would be able to figure out the exact answer. There's the exact answer, though. What number can you multiply by 4 and then multiply the other number by 3, add them together, make 14, and then also do all this and get it to be negative 3? Well, these are the only two numbers that would work in both. Cool. All right. I'm going to give you another one, but I'm going to have you kind of try to do it on your own. Okay? So I'm out of room on this side. I'm going to have to flip my paper over to go on to number 3. Hopefully you have this down. All right, let's try number 3. Let's do two slope-intercept equations. Y equals 2x plus 7, and y equals x minus 1. All right, I'm not going to walk you through this one yet. I will once you've tried it. I want you to try it, see what you get for your answer. If you would like, you can post your ideas in chat. You don't have to do it completely on your own. You can get help from your classmates, but I'm not going to help you right away. I'm going to let you try to do it first. All right, thanks, Nicole. Yeah, I saw. So you guys, you try to do this one. And if you want, you can share your ideas in chat. I'm going to change it a little bit. There we go. So this is one all of you should be working on, but you can also get help from each other. So I'm not saying much conversation. If you get the answer and you want to post the answer publicly for everyone, that's fine. If you are wondering about a step along the way, you can send me a message, Mrs. Flood, or post it for everyone online. We are here to help. So let me know kind of where you're at, or if you got the answer, post it so we can all check and see if we agree. Do any of you want to post your answers publicly so we can compare? This is new for some of us, right? So it's fine to make mistakes. So don't be worried about posting your answers publicly, but I'll leave it up to you if you want to. Just we're trying to share, we're trying to get to the right answer, right? I have 4 of you who have sent me it privately, which is fine, but doesn't anyone want to share with the whole class? Ah, thanks, Cooper. Anyone else? Thank you, Ellie. So we have one idea that's been shared with the class. Anyone else want to respond to Cooper's or share your own? Do you agree? Do you disagree? I think I've seen like 3 different answers come to me so far in chat, so I know that there's some disagreement. All right, we can walk through this one together. So slope intercepts, right? This is kind of cool because y is all by itself over here and it's all by itself over here. So when you solve this, you can just set them equal like this. The 2x plus 7 is going to equal to x minus 1, or I don't know why, but I wrote it the other way around. X minus 1 is 2x plus 7. Okay? We have variables on 2 sides. We need to get them on one side. So you always move the smaller one. You cancel out the smaller one. So minus x minus x. And so I believe this would be your answer. I'm curious, where do you think the tricky part of this problem is? Like, where do you think people might make mistakes? It's like, here's what I know. I noticed these were both y's. That's why I set them equal to each other. The 2x plus 7 came here, and the x minus 1 was over here. Okay, thanks, Ethan. Thanks, Maya. Yeah, that's what I was thinking too, Nandika. So yeah, with substitution, you always have to be careful. Like, so far we've always we're always left with x's so far. There are times maybe you'll be left with a y. It just kind of depends. So how did I get the -9? Well, first I got my x, which is all here. So I got to -8. And then I could either plug the -8 in here or in here. I chose to put it in this one. So then I just had -8 minus 1. And so if you take away 1 from -8, you get to -9. I could have done it in this one. It would have been 2 times -8, that's -16. And -16 plus 7 would be -9. Yeah. Okay, let's try one more of these, kind of the same as before. We'll do it all as a class here. Maybe more people will post their ideas publicly too, so we can help each other out. Your homework today is going to look just like these. You're going to have either slope intercept, standard form, maybe point slope, and you're going to have to find a way to substitute and solve. You don't have to worry about any graphing today. Okay, here's our next one. We're going to do Actually, you know what? I'm going to give you some equations not in any of the three linear equation forms. You're going to have to kind of change them around a bit before you can solve them. Let me show you. They'll kind of look like standard form, but not quite. Let's say we had 2 equals 2y minus x, and 23 equals 5y minus 4x. Okay, so you're gonna have to do a little bit of changing the equations a little bit before you can jump in and solve. So write those down. You try these ones out. And if you get stuck, if you have a question, post it in chat so that we can help each other out. Or if you get to the answer, post the answer in chat so we can help each other out. Cooper, I'm thinking it's kind of like problem 2 that we did. In problem 2, we had to add 2x to both sides before we could start our substitution. So like here, I'm thinking you're probably gonna have to like move some pieces around, kind of do some inverse operations before you can do a substitution. Would someone be able to help us with that? Which equation do you think you're gonna change before you do your substitution? Okay. One of you says the first one of you says the second one. Either one's fine. I was thinking more of the first one. And someone else says the first one. But you could do either one. So like over here, if it said like x equaled, that'd be really cool. But it doesn't. So I'm thinking maybe you could change it so it does. Or you could change it so it says y equals. Can someone tell me, what did you, those of you that chose the first one to change, can you tell me what you got when you changed it? I think that could help for those of us wondering. Thanks, Tina. So let's see, it looks like you did, so it looks like you could go like this. You could go -2, and so you'd have 0 equals -2 plus 2y minus x. And then if you add x to both sides, you have x equals -2 plus 2y. Look at that. Okay. I'm not going to help you anymore right now. I'm going to let you keep going. But see, now it's set and ready for the substitution because x is all by itself. All right, so let me know if you have questions or if you get to the answer, post the answers there and see if we get the same. Or you don't have to wait to get to the final. If you figure out one of the pieces, you can post it and we can share. Thanks, Tina. Anyone else? Let us know when you get to your answer. Or if you get like a part on the way, let us know so we can compare. Thank you, Ellie. This is a very long one, I would say. I think this is about the longest that they get for us. I've heard 2 answers so far. All right, let's walk through it together. Thank you, Ethan. Boy, I see lots of places in here that mistakes could show up. Okay. First thing is you always need to figure out what one of the variables equals. And so that's what sometimes it just tells you at the beginning. Sometimes, like in this case, you had to, it's called manipulating the equation. You had to manipulate the equation and change it. You got what one of the variables was. So we did that already. So what I'm going to take this x and we're going to put it in right. So hopefully you can see that. I want to cover up some of my papers. Here we go. All right. So that's how I get to this part. Let me have questions like, okay. And now it's all in parentheses because it was -4 times x, so -4 times this. So I know I'm going to have to do a distributive property. Remember, you have to take minus. You have to take that operation with the number when you do the distributive property. And that's how I get to this step. 26 is 5y, and that's going to be plus 8. And then it was plus -8y, so minus 8y. And then we notice some like terms. 5y's and take away 8 of them. So we get that. And then we subtract 8, divide by -3. So a tricky thing with systems, if you get this y number wrong or you get your first number wrong, there's no way you're going to get this one right unless you get lucky. So if your answer was wrong, chances are your mistake came up here somewhere.